Okay. So we're going to learn argument. All right. So there are two types of argument: deductive argument and also inductive argument. So basically, inductive argument is to uh, form a specific conclusion based on general statement, right? So inductive argument is the opposites of deductive argument, which we are forming a general conclusion based on the specifics examples. We say examples. So deductive argument is always true, okay, but inductive argument can be true, can be false, right? So general to specific, we call it deductive argument. So inductive argument will be specific to general. So how to identify general and specific statement, right? So we go to the example. Okay, so now we are going to identify whether given examples here is a example here are deductive argument or inductive argument. Okay, you see A here, the area of a circle is pi r square. Okay, so this will be our premise, right? Circle A has a radius of 7 centimeter. This is also called premise, right? But then in conclusion, the area of the circle A is 154 centimeters square. So you can see here, the premise one, okay, so premise one. So this is premise one, premise one. And then the conclusion is the area of a circle is 454 centimeter square. So you can see here, this is general statement, general. So the area of a circle, we don't know what type of circle, but it's a circle. So we will use this formula, right? Pi r square. So in BM is pi j square, j kuasa 2, right? Luas bagi sesuatu bulatan. So ini adalah general statement, right? Then conclusion, the area of a circle A, so now is specific. Circle A is 154 centimeters square. So this is specific. So if general to specific, so this is called deductive. Okay, deductive argument, right? So this is called general statement. This is specific statement. So you need to know, identify which one is general, which one is specific. Okay, now we go to C here, right? 1 to the power 0. So here, these are all called premises, right? Premises is a statement. So statement 1, statement 2, statement 3, statement 4, and the conclusion is n to the power 0 equals to 1, where n equals to 1, 2, 3, 4. So our premise one is this one. This is our premise one. 1 to the power 0 equals to 1. So this is specific. Okay, specific statement. And then our conclusion, C is for conclusion. So it's n to the power 0 equals to 1, where n equals to 1, 2, 3, 4, and so on. So here must be 3 dots. Okay, later on I'll teach you. Right? So this is general. So how we know general? Because we use n. N can be anything. Right? Any here cannot be anything. Can be we call it round number or in integer, right? We call it integer, right? So here is integers. Okay, so we can see here is specific to general. So specific to general. Therefore, this is inductive, right? Argument. Right? So specific to general, inductive argument. Then we go to E. Or, when you see this word or, right? So this means is general or, right? All class 4 select pupils score A in mathematics test. So this is our premise 1. So our premise 1 is all class 4 jelek pupils, all right, pupils scored A in the mathematics test. Okay, I use short form, you don't use short form, M test. So this is general or specific. So you see here, all that means this is general, right? So if general, then what is the conclusion? So before that, we go to premise 2. Camellia is a pupil in class 4 Jelek. Therefore, or conclusion, Camellia score A in mathematics test. So our conclusion is very specific, right? It's telling about Camellia. So Camellia score A in maths test. So this is specific. So we are general to specific. So this one is deductive, right? Deductive argument, right? So again, right? So general to specific, deductive argument. So specific to general, inductive argument. Let's see some more examples. So we go to B here. Again, you see the word all here. So all multiples of 6, all multiples of 6 are multiple of 2 and multiple of 3. So this is premise 1. So I don't write now, right? I don't write, but you write it on your notes there. So this is, sorry, not specific, but general. And then 72 is a multiple of 6. So this is premise 2. Then hence. So this is conclusion. So our conclusion is very specific. It's talking about 72, right? So this is specific. So from general to specific, so this is deductive argument. So it's deduce, deduce, from the word deduce. All right, so multiples of 6 or any multiple of 6 must be multiple of 2 and multiple of 3, right? So, and 72 is a very specific example of multiple of 6. So hence, this specific number 72 must be a multiple of 2 and 3. So it's specific example. All right, so come to D. So D, we have 4 premises here. So we're looking at premise, one of the premise 1, right? Premise 1, you see here 1, 2, 3, 4. This is specific, right? So we have specific. Then our conclusion is this: 2n cubed minus 4, where n equals to 1, 2, 3, 4, and so on. So on must be 3 dot, and above. So this is general. So specific to general, it is inductive argument. All right. Okay. So I think it's quite clear already. Then we have another one. Tigers are carnivores. Lions are carnivores. Crocodiles are carnivores. Penguins are carnivores. Is it? Penguins are carnivores? I'm not sure. I'm not good in bio. So this is all our premises, right? So tiger. So you know what is tiger? Tiger is very specific, right? So tiger is carnivores. Eat meat only, right? So eat human also if very hungry or you disturb its the territory, then it will eat you, right? So it's carnivore. So it's very specific. Then our conclusion, this is all the conclusion. You see the conclusion, all, using all here. Here also all. So all the animals above, so we are talking about these animals, are all carnivores. So this is general. So specific to general. So this is this is inductive argument. So something across my mind. So that's why I think about deductive. All right. So okay. So is it true here? All of these animals are carnivores, right? Penguin only eat meat. Sure. Only eat fish. Can eat something else? I'm not sure, right? So you love bio, then you tell me, right? Okay, so this exercise, please do. Right, so the assess practice 3.2, all the questions in page 74, and comprehensive practice question 10, page 90. This is in textbook for science 1, for science 4E, 4C later on, right? Okay, now argument. So argument, there are 3 types of argument. So I don't like you use form 1, form 2, form 3. Yeah? So this one is use type, type 1, type 2, and type 3. I don't know why new syllabus they use form 1, form 2, form 3. So some sort like they are learning. Form 1 learn OA is B, C is A, C is B. Form 2 will learn if P then Q, P is true, Q is true. Form 3 will learn if P then Q, not Q is true, not P is true. But actually, these are the 3 types of argument. Deductive argument. So you can see here, a deductive argument is said to be valid if all premises and the conclusion are true. So here, we are not looking at this later on because it's contradict with this. And the argument is valid if it complies with any forms of deductive argument listed above. Okay, so here we are looking at the argument is valid or not. We are not looking at the deductive argument. Deductive argument here is all correct, must be correct. So here we are looking at the specific argument. So if the argument is valid, if it complies with any form of the deductive argument listed above, these 3 forms, so it follow the rules. If A is B, all A is B, C is A, C is B. If you said all A is B, C is B first, if you said C is B, C is A, then this is not valid, right? Okay. If P then Q, you said Q is true, P is true. This is also not valid, invalid, invalid, right? So this one not Q is true. So you terbalik become not P, not Q. So this one also invalid. Okay. So what is sound? Unsound. We are using sound. Sound is the bunyi, right? Unsound. Okay. So in English, sound and unsound is something. If all the premises and conclusion are true, we call it a very sound argument. It's very strong argument, right? Sound, unsound. If one of the premises or the conclusion is false, then it's unsound argument. Okay, it can be valid argument, but unsound, right? Valid argument, unsound. If valid argument means it follows the 3 type of argument, but one of the premises or the conclusion is false, right? Okay. If invalid, then it must be unsound. So invalid, you can see here, the argument have 2 types. We already learned this just now. Now we're going to learn valid or invalid. So if valid, then it can be sound or unsound. If invalid, then we cannot determine sound or unsound. It's already invalid. So no point to find out it's the premises or the conclusion is true or not, right? So it said sound or statement are true. Okay, so let's go to, I hope that you understand. Inductive is only 2, correct, incorrect, right? So this one, we are not looking at this very often. We are looking at deductive argument. Argument, deductive argument. Valid or invalid. Valid must be follow the 3 type, right? 3 types of argument. Type 1, type 2, type 3. Okay, sound must be all the statements are true. Unsound, 1 false. Then it becomes unsound. Okay, so let's see. All multiple of 16 are even numbers. 64 is a multiple of 16. 64 is an even number. So let's see. Okay, our form number 1, or type 1 is all A is B. C is A, C is B. So here is A, this one is B. So C is A. So C here, A, C is B. So this is valid. So is it sound? Okay. 64 is multiple of 16. So you use your calculator. 64 divided by 16. So you get 4, right? So this is a multiple of 16. Correct. This one also correct. Right? True, true. 64 is an even number, also true, right? So true, true, true. So this is valid and sound. Okay, valid and sound argument. Okay, now we go to the next one. All basketball are spherical shape. Okay, all basketball, A, spherical shape, B. C is the earth. C is spherical shape. C is B. C is A. So you can see here, it doesn't follow the rules of type 1. All A is B, C is A, C is B. But now it's all A is B, C is B, C is A. So this is invalid argument. Right? So invalid. Why? Because premise 2 and conclusion doesn't follow type. Because it does not comply with form 1 or type 1. Okay. So the next one, if W is less than 9, then W is less than 19. So this is P. We are using P now. P, if P is Q, this one is P is true, Q is true. Or we can say this is, in other words, I use C is P, C is Q, almost the same like this. So this one is follow type 2, right? So type 2, so this is valid. Okay, so we want to see whether this is sound or unsound. So number less than 9 is number less than 19. 5 is less than 9. 5 is less than 19. So true, true, true. So this is valid and sound. Okay. All right. So you can see that. Then we go to the next one. Premise 1. If A not equals to 0, then ax power n plus bx plus c is a quadratic expression. Okay. So if A not equal to 0, then this one is a quadratic expression. So we can see here is the P, this is Q. P is true, Q is true. So this is valid. Because why valid? It is comply to form number 2 or type number 2. But is it sound or unsound? So you can see here, this is unsound because if A not equal to 0, then this one is false, right? So if this one is true, but this one is false, okay? Premise 1 and premise 2 are false, then, but we say valid but unsound, okay? Because one of it is false, so it's unsound. So quadratic expression, the n must be 2. Okay, so this is unsound. Valid but unsound. Okay, so I hope you can differentiate between valid, invalid. Valid must be the argument must comply with either form, either type 1, type 2, or type 3. All right, so sound, unsound. Sound must be all the statement must be true. All right, if one of the statement is false, then it's unsound. All right, so if the statement doesn't comply with type 1, type 2, type 3, then it's invalid. So no need to determine whether it's sound or unsound. Okay, let's go to the next one. If k is divisible by 8, then k is divisible by 4. Okay, k is divisible by 8, then k is divided by 4. So this is p, this is q. So here 12 is not divisible by 8. So now is c, we use c, yeah, because specific c is not p, c is not q. So our form tree or type tree is if p, then q, not q, not p, or c not p, c not q. So here is c not p, c not q. So it doesn't comply with this. So this is invalid. So full stop, right? Because it doesn't comply with form number 3 or type number 3 deductive argument. Okay, premise, and we go to G, G first. If K bigger, greater than M, so this is P, K minus M greater than Q. So K minus M less than or equal to 0. So now it's opposite Q, right? Negation of Q. Bigger than K, bigger than 0, the opposite is smaller or equal to 0. Then K is smaller or equals to M. So not P is true. So this is valid. Okay. So, and is it sound? Sound. Correct? Is true. Here, true. So K minus M, if K minus M less than 0, then K must be less than M. Right? So this is sound. Valid and sound. Okay. So all the statement here true, 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 true. Okay, then we go to F. If K is an even number, so when you see if word, then that means this is P, this is Q. If K is an even number, K plus 1 is an odd number. If 4 plus 1 is an odd number, okay, now C is Q. 4 is an even number, C is P. So our form type number two. So if P, then Q. P is true, right? Or Q is true. So if C is P, C is Q. So here is C is Q, C is P. So this is invalid. Not sound and not, right? So invalid. Here two are invalid. All right. So I hope that you understand this. So I don't repeat again. Okay. So you just go through the recording later on if you still don't understand, right? So just want you to do the exercise in 3.2 or the equation in page 77 for science 1. Okay, so valid again. Okay, conclusion, valid must be complied to 3 form. And okay, so invalid doesn't comply with the 3 form, 1, 2, and 3. Okay, if valid, it can be sound or unsound. Sound is all the premises and conclusion true. Premises, one of the premises or conclusion is false, then is called unsound. Sound, valid sound or valid unsound. So invalid only. So invalid will be invalid only. Don't go and determine whether sound or unsound. So wasting your time. Okay. So this is valid and unsound or unsound, and invalid, valid. Okay. So now we go to the next one. Complete the conclusion based on the 3 types. So how to do this? Okay. Okay. All equilateral triangle have 3 equal lengths. So when you see the word AO, then it's type 1. So type 1 is O, A is B, O, A, B, right? So we have to determine what is A and B. So equilateral triangles, that is A, then have 3 equal lengths, that is B. So we don't look at the A, cancel it. Then you can see, you have to remember this. C is A, C is B. So what is C here is A, B, C. What is your A? Equilateral triangle. So the answer here must be C, B. What is CB? A, B, C has, so singular, we use has 3 equal lengths. Okay, all right. So, okay, here's your answer. So now we go to the C. If A is an even number, then A plus 1 is an odd number. So when you see if, then it is either type 2 or type 3. So we look at the second one. Is there any not word there? Not word. Negation, huh? Negative word there, not negative word. Or you see the opposite sign or not? Huh? Opposite sign. Huh? So you can see here, no, not at all. Huh? So that's mean this is using if P, then Q. Okay, so P is true, Q is true, or C is P, C is Q. So here, because C here can be specific. So you can see if this is P, this is Q, right? So 4 is an even number, C is P, C is Q. So what is C? 4 plus 1. A is 4 lah. Then A plus 1 is C, is an odd number. That is your answer. Okay. All right. So another one. If A equals to 5, A plus 1 equals to 6. So this one is very clear, is if P, then Q. So I just want to introduce you a symbol, very simple symbol. If P, this is P, if P then Q, P true, Q true, right? So it's easier for you to remember also. Okay, right? So here is all, A is B, C, A, C, B. So this one is easier for you to do type 1, type 2. Okay, so, right? So CP, CQ lah. P is, if P then Q, CP, CQ. So here is no need to P, right? So it's either CP or P, Q. So here directly just follow A plus 1 equals to 6 because this is assumed as true. Right? So this is understood. We don't write true there. It's true lah. Okay, A equals to 5 is true. A plus 1 equals to 6 must be true also. Okay, right? Okay, then we go to the next one. All pentagon have 5 sides. Okay, so this one is type 1, right? Type 1. So all, right? All, A is B, C is A, C is B, right? So all pentagon A have 5 sides, B, C pentagon CA, CB. So what is C? PQRST has 5 sides. Okay, so remember, don't add any unnecessary word there. So just follow the argument given, right? So don't be kepo lah, to put anything, right? If the number is in word, in numbers, don't change it into word, wording. So don't be like, for example, if x equal to 3, don't go and change to x equals to 3. So this one, no, don't do that. So next one, if A is an odd number, then A squared is an odd number. So now we have not here. So that's mean if P, then Q, right? All right, that's mean not Q, not P. So we determine first, this is P, this is Q. So now is A is not an odd number, so not Q. So here must be not P. So not P, how to do? A is not an odd number. So meaning that if a square is not an odd number, sure, a is not an odd number. But a is not an odd number, a square is not an odd number, can be wrong. Okay, can be wrong. Okay, because a is an odd number, but if a is a negative number, we cannot call it an odd number, right? Okay, so it can be wrong, right? Can be false. Sorry, not wrong. We cannot use the word wrong. We have to use the word false or true. Okay, so don't use the word wrong or incorrect, right? Or true, correct or incorrect, right? So don't use that word. Okay, then the next one, if x equal to 3, x plus 5 equals 8. So this one, there is a symbol not equal here. So we are using type 3. So x x plus 5 not equal to 8, then the answer must be x not equals to 3, because this is if p, then q, not p. Okay, so this is how you determine the conclusion. Okay, for an argument. So it's either type 1, type 2, or type 3. Okay, so now we go to complete the premises of the following. Okay, this is quite challenging, but we just follow the rule, don't worry. So you see, the first one, if I see or, then I have to remember or A is B, or A is B, then C is A, C is B. So this is A, this is B, then this is C, the whole thing is C, B. So what is CA? CA is the straight line ABCD are parallel line. So because parallel line is A, ABCD is C, so C is A. So everything, actually the answer is in the question. So no need to crack your head. You just need to determine which is the answer. All right? So for my previous experience with the weak student, they will get this correct, although they don't understand. They just do like this. This is A, right? So this one must be a pair, A and A, right? If you see here already appeared, here only appeared one, the answer must be these two combined. Okay, right? So it's just that. So very easy, right? Premise, this question also form number one. This is form number one, right? Or part one. So you can see all we cancel. This is interior angle of equilateral triangle 60. So this one you need to know where is your A, where is your B. So here is our A. The whole thing here is B, right? So you see the interior angle of ABC, this is C, here is B. So C is A. Where is C is A? ABC lah, is an equilateral triangle. So this one is you need a bit of language skill lah. You need to know where is A, where is B. So this question is a bit tricky lah. So if you can understand this question, should be no problem for others, right? Now we go to premise 1 and 2, this one. So this one is which form. So you can see here. The other thing you can check whether, if you don't remember which form, then you look at this, right? If P, then Q. So P to Q. So you can see here, X not equal to 16. So it's not P. So here it must be not Q. So it's type 3. If type 2 is P, not P, then Q. So P, Q, right? PQ. So you see here, P is here. So this one must be type 3. So what is the answer? So here already sudah buat kan? So the answer must be X equals to 4. But here using equal become not. So the answer not. Okay. So that's how you determine. Right? Okay. So next we go to So the answer is, all right, so let's see, what's the answer? Okay, not equals to 4. So you can see repeated, right? The answer repeated must be a pair. So next we go to this. The sum of the digits 3. Okay, if I don't understand the question, I don't care. So I just what I do, I just say, draw it out. This is P. The whole thing is Q. So if and then I throw it away. Then we see 712 is a multiple of 3. You see, find here. The number is multiple of 2. So 712 is multiple of 3. So this one already done. Then the answer must be here. So what's the answer? Sum of the digits of a number change to 712. That is your answer. The sum of the digits of 712 is divisible by 3. This one must be the answer. Right? So if P, then Q. So we are using type 2. P, if P then Q, P is true. C is P, C is Q. Right? What is C? C can be in front or in the middle lah. In this case, P is here. Right? Sorry, C is here. A number is general. Specific is 712. So you need to know a bit on grammar lah, or on the English lah. Huh? The next one, okay. If x bigger than 6, x bigger than 4. So can we use or here? So you need to know. Can I use or? Or A is B, C is A, C is B. Can I say, oh, this is A, this is B. So here is CA. So cannot, right? So can I say all x equals to bigger than 6 is x bigger than 4? Cannot. So our answer can be type 2. Type 2 will be here. This is PQ. So PQ, so we just write if x bigger than 6, then x bigger than 4. So the answer can be type 3 also. So type 3 is P. If P, then Q. Not Q is true. Not P is true. So we just change the symbol. So it becomes if x bigger or smaller or equals to 4, okay, then x is smaller than or equals to 6. Okay, so then if this is P, this is Q, so not Q. So not Q will be x bigger than 6, right? Not P will be x bigger than 4, right? So there are two question type answer, right? So if form 2, then x bigger than 6, x bigger than 4. If form 3, x less than or equal to 4, then x less than or equals to 6. Right? So next one. Right, so this one, if, right? So this one is type 2. Type 2, you see the symbol is the same. And then this is 10, 10. Right? You see here? How do I determine? So the answer here must be less than 6. So what is the answer here? X already used, right? So 5 must be right again, right? So or you use the convention, systematic way is P, then Q, C is P, C is Q. So what is our P? X less than 6. So what is X? 5 less than 6, okay? So this one, ABCD is a pentagon. ABCD have 5 sides, okay? So our answer cannot be type 2 because type 2, this is specific, right? So we want a general. Remember the general to specific because this is deductive argument. Okay, so this question, you must use or. All pentagon have 5 sides. So this is C, A, C, B. So we use or. A is B. A is pentagon, B is 5 sides. So all pentagon have 5 sides. So this is the most correct answer lah. The next one, if the product of Y is not, is it not right? So this is not Q, not P. So the answer is P. If P, then Q. What is P? If Y, okay, if Y is an even number, then the product of Y in 2 is an integer. We throw the not here because the not already repeat itself. Okay, repeat itself, throw it away, then the answer must not have not there. If the answer, one of the answer is not, the other one must, the not is only appeared one, the answer in the previous one must has not there. Okay, so this is how you determine the age here, right? So this is type 3. Okay, so do the exercise here. Okay, all right, so the next lesson we will continue later on.